Welcome to our mathematics lesson, and today we are continuing with ordering fractions. So earlier on we looked at fractions when we are able to compare them. We also looked at a way of identifying which fraction has got a higher value or greater and which one is less. Now, today I want to look at a group or a set of fractions, and this time round we try and rearrange those fractions either in ascending order or alternatively in a descending order. So let us look at this question. Place the following fractions in an ascending order. So we have the following question. Place the following fractions in an ascending order. The first one, 3/4, 4/5, and 2/3. And the second one, 1 and 3/5, 7/4, 3/2, 2¼ and 11/5. So in our solution here, we shall start with the first one. In our solution here, we have got fractions, and the main thing we need to look at is the denominator. When you look at the denominator here, you will notice that they are not the same. So if that is the case, then we shall be required to find a better way of handling a group of fractions so that we are able to come up with the same denominator, so that we are able to come up with the same LCD, so that will help us to simply tell us which one is supposed to be less than the other one, and then we start arranging them in either ascending or a descending order. So it is very necessary that we know how to find what we call LCD, as we saw it earlier. That is the lowest common denominator. So what is the first approach? What is the lowest common denominator for 4, 5, and 3? Now to get the common denominator for this, it is very simple, as we saw it earlier on when we were looking for the LCM, that is lowest common multiple, where for this particular case we only need to have the number and then the factor here. So the numbers that we have is 4, 5, and 3. The least factor that can divide here is only 4. For 4 is 2, we get 2. This one is maintained. Then for 2 we get 1. This one is maintained. Then we have a 3. We have 1 here. 3 is divided, we remain with a 1. Then we have a 5 here. Then we come to 5, we get 1. So the LCD for this particular case is 2 power 2 times 3 times 5. That one is going to give us the LCD, or the lowest common denominator, which you'll find is 60. Now, having known our least common denominator is 60, now we can come back to our question and proceed. So we have a 60 as our LCD. Therefore, for these problems that we have, you'll notice that we shall have 60 as our denominator. 60 divided by 4 gives us 15. 15 times 3, you get 45. Now, so 3 over 4 is equivalent to 45 over 60. And then for the second one, we have 60 as our denominator, divided by 5. And when you divide 60 by 5, you get 12. Then 12 multiplied by 4, you get 48. So we are saying here that 4 over 5 is equivalent to 48 over 60. Then the last one is 60 as our denominator, divided by 3, we have 20. 20 multiplied by 2, you get 40. So 3 over 2 is equivalent to 40 over 60. Then what comes is, can we now rearrange this correctly and see what it means? So since the denominator is the same, it is 60, then we said earlier on, the least numerator means that is the smallest fraction. So because we are arranging it in an ascending order, the least here is 40 over 60, followed by 45 over 60, and then finally 48 over 60. Having done that, we look at the original values. We want to rewrite. We rewrite and give the original fractions. So rewrite the fractions in original form. If that is the case, then we shall ask, 40 over 60 was equivalent to 2/3. So the order will be 2 over 3, followed by 45 over 60 was the same as 3 over 4. So in ascending order, we have 3 over 4, and finally 4 over 5. So we have been able to arrange the group or a set of this fraction in an ascending order. That is how we do it. Let us look at a similar problem, but a bit different and mixed with other mixed numerals, improper fractions, and see if we are able to also arrange the same in this manner. So our problem is here, and you'll notice that our problem is 1. We rearrange 1 and 3 over 5, 7 over 4, 3 over 2, 2 and a quarter, and 11 over 5. 11 over 5. Now we have mixed numerals and improper fraction. We cannot operate when they are in this manner. So we have to change where we have mixed numerals, we convert and have it in improper fraction form. So this one is affecting only two numbers and we need to work on that. So this one, to convert this one, it is 5 multiplied by 1 plus 3, which gives us 8 over 5. So if you don't want to have 1 and 3 over 5, you just write 8 over 5, 7 over 4 remains, 3 over 2 remains. This one is 2 times 4, which is 8 plus 1, it's 9 over 4, and finally 11 over 5. So the whole of this group is a group of improper fractions. Now, the next step that we take is to find the LCD. That is the lowest common denominator of the following digits of 5, 4, and 2. 5, 4, and 2. We have 5 here, we have 4, we have 2. So we have exhausted all the denominator in this particular case. And you'll find that LCD of this is 20. So the LCD of 5, 4, and 2 is 20. Then now we come into this, having known that our common denominator is 20. 20 divided by 5 will give us 4. 4 multiplied by 8 is 32. Second one is 20 divided by 4 is 5. 5 multiplied by 7 is 35. Or 20. Next one, the denominator remains 20. 20 by 2 is 10. 10 times 3 is 30. 20 divided by 4 is 5. 5 multiplied by 9 is 45. And finally, 20 by 5 is 4. And 4 multiplied by 5 is 44. So we have this. Remember, this is a group of equivalent fractions. Where equivalent in this particular case is that 32 over 20 is equivalent to 8 over 5, which was the same as 1 and 3 over 8, and so on and so forth. So this is arranged according to our initial group of fractions. So having reached here, we need to rearrange. Let us see which one should be the least. The least should be the one with the least numerator. The least numerators on this is a 1, followed by this one a 2, followed by this one a 3. We have a 4 and a 5. So when we rearrange this, you'll find that the least is 20, is 30 over 20, followed by 32 over 20, followed by 35 over 20, followed by 44 over 20, followed by 45 over 20. Now, we rewrite this to their original format. So we shall ask ourselves, 30 over 20, which we have here, was the same as the third fraction, which is 3 over 2. So the first one, the order will be 3 over 2, followed by 32 over 20 was similar to 1 and 3 over 5. The third one is 20. The third one that we have is that 5 over 20, and that 5 over 20 is equivalent to 7 over 4. The fourth is 44 over 20, and 44 by 20 is similar to 11 over 5. And finally, what is remaining? 45 over 20, which is the same as 2 and 1 over 4. So by this, we have been able to rearrange our set of fractions right from the way they were originally to the order of ascending. So this is the right answer, ascending order for this group of fractions. Let us now look at place values. Place values in decimals and ordering in decimal. Now I want us to look at this situation. In a small room or even in this classroom, you may go out for break. When you come back to the classroom, one student will come in first, maybe two, a group of two, maybe three, and so on. What you learn is that the total number of pupils in this class will keep on increasing. As it increases, it is increasing by a whole number. Because we don't have a fraction of a human being. So every time a child comes from break into the classroom, the number of students increases by a whole number. So there is a situation where this does not apply. And especially when we are looking at things like the age. Age is continuously increasing. The height, the weight. This and others, they don't increase with a whole number. But they increase in a certain way that there are areas that we need to look at, and those are the areas I want to look at as decimal. I want us to take a simple example from a stopwatch. If you have a stopwatch, I want you to try this and see what you are getting. Are you going to be accurate or you are not going to be accurate? Just take a stopwatch and we try this together. Now, as I've said, place values in decimals and ordering decimals. Besides increasing by whole numbers, animals increase by whole numbers, human beings increase by whole numbers, there are circumstances which do not add up as whole numbers, but they increase with a certain level. And that is the example is the age, height, weight, and so on. Somebody may even choose to say, I'm 12 years old, I'm 15 years old. But is it exactly 15? You'll find that maybe it is 15 years or it's 12 years, 51 weeks, and maybe 2 hours, and so on. So it's not that it is easier for us to have at the age of a person increasing by a whole. Now I want you to take your stopwatch, and as you take your stopwatch here, then the situation is this. We want to see if we are able to start the stopwatch and stop the stopwatch at given intervals. If it is possible, then we shall see how smart we are. Now, I want us to start to stop the stopwatch at exactly 12 seconds. At exactly 12 seconds. So this is my stopwatch. Now here, I'm going to start. It has started 1, 2. As I count with it, that is 4, 5, 6, 7, 8, 9, 10, 11, 12. I've pressed 12, but you notice that it didn't stop at 12. On the other side, there is a point. So when I tried this, my stopwatch has stopped at 12.65 seconds. So this is approximately 12 seconds. But it's not 12 because of the error of pressing. So that is it. Let's try again after refreshing. This is 12 seconds. Let us try to stop at 8 seconds and see. Is it possible for us to get exactly 8? Here we go. So we want to see if we get exact. Good. So start. Now the stopwatch is running 4, 5, 6, 7, 8. I've tried to be accurate, but it is now, if you look at it clearly, it is at 8.30 seconds. So when I try to stop here, I got 8.30 seconds. What I'm trying to say here is this, that it is not always that all the time, it's not true that all the time anything increases by a whole number. We have seen the seconds increases by some decimals. To make a whole second, we need 100 decimal points. So total of 0.100 gives us 1 second. So that's why we are saying it does not always mean that any variable will increase by 1. So our major interest this time is about decimal points. At this issue of stopwatch, you can try it back at home and see how accurate you are. You can try to start and stop the stopwatch and see how many seconds, how fast are you to start and stop the stopwatch immediately. If you are too fast, you'll find you are below 1 second. If you are too slow, it is more than that. That is all about the decimal. So let us see, what is this we are calling decimal and how is it used in mathematics? At the decimal point, so a decimal point is simply used to separate the whole number from the decimal or the fraction part. That is what a decimal is. And when dealing with decimals, in this particular case, we need to look at what we call the place values of each side. So we are going to look at place values of decimals and see what value do they normally carry. So I want to arrange this, and as we arrange this table from hundreds, tens, ones, tenth, we have hundreds, we have thousands. Now I want us to consider $428.357. Now, looking at place values, as I've said earlier on, we say that a decimal point is simply used to separate a whole number and a fraction or a decimal part. So before the decimal point, we have the whole number. And from the whole number is where we start by ones, tens, and hundreds. So at ones here, we have, what we have at ones is 8. Then we have 2, we have 4. And then decimal part starts with the tenths, which is 3, 5, and 7. What I have, this is 428.357. So at this part, we have, before the tenth, we have a decimal point. That's where we have the decimal point. Any number coming after the decimal point, its place value will start from, we normally start with the closest, the tenths, then a hundredths, and then a thousandth. So what we have, the first one, is 4. What is the total value of 4? You realize that it is at the place value of 100, so this one here is equivalent to 4 multiplied by 100. So this is the value of digit 4 at a place value of hundreds. For tens, this is equivalent to 2 multiplied by 10. And for ones here, we have 8 multiplied by 1. Now, after the decimal point, on the other side, after the decimal point, we have the digit 3, but at tenths, which means that the value of 3 here is 3 multiplied by 1 over 10. That's why we are saying a tenth. 5, it's at a place value of 100th, so it will be 5 multiplied by 1 over 100. And finally, 7 will be at 7 multiplied by 1 over 1,000. So when you work out this, you'll find that what we shall get is this one will give us 400. This one will give us 20. This one will give us 8. This one will give us 3 over 10. This one will give us 5 over 100. And 7 over 1,000. That is what we are getting. So generally, what am I trying to say here? I'm saying this: decimal points and decimals have got a place on a place value table. And that's why we start from after the decimal point on the right, we have the decimal part. Before the decimal point, on the left, we have the whole number part. And its values, they simply carry the value according to its position in the vertical column, as we've seen here. So let us understand the decimal place value by looking at a few of the questions. So look at the question. What is the value of digit 8 in the following numbers? 1 is 12.85 and B 6.1287. Now, the value of 8 here, as we saw on the place value table in our solution here, will be the 8 as a digit that we have multiplied by the place value of 8 is a tenth. So it will be multiplied by 1 over 10, which will give us 8 over 10. 8 over 10. Now, why are we using this? Because 8 is in the first column. It is simply in the first column after the decimal point, which is the 10th or 10th column. 8 is in the first column after the decimal, which is in the 10th column. That's why we say the value of 8 is the same as 8 multiplied by 1 over 10, which is 8 over 10. Let's look at this. The value of 8 is what? It is going to be, the value of 8 is going to be 8 multiplied by, this is tenths, hundredths, and thousandth. So it is 1 over 1,000, which will give us 8 over 1,000. Why? Because 8 at this point here is in the third column after the decimal point, and the third column after the decimal point on the right, this one is the tenths, then we have the hundreds, and this one is the thousands. Thousandths, and finally 10 thousandths. Note that it's thousands with TH. So I'm saying 8 is in the third column after the decimal point on the right, so it falls in the category of thousandths, and that's why the value of 8 is 8 multiplied by 1 over 1,000, which gives us 8 over 1,000. Let us look at changing decimals. Changing into decimals. And question says, express each of the following proper fractions and mixed numerals in decimals. Express each of the following proper fractions and mixed numerals into decimals. A is 7 over 10, B 5 over 100, and C 3 and 17 over 1,000. Now the first one that we have, it is very simple and straight, as you can see. To convert, looking at a solution here, for the first one, 7 over 10, it is so straight. This one will be 7 over 10. We are dividing by 10. This is the same as 7 multiplied by 1 over 10, which implies that 7 lies in the first column of the place value after the decimal, which is a tenth. And if that is the case, you'll find that this is the same as 0.7. So it is 0.7 because it is in the 10th column. For the second one here, 0.5. This 5 over 100, sorry, is the same as 5 multiplied by 1 over 100. So this simply is trying to tell us where the position of 5 when it comes to the place value, and it's going to lie in the place where we have hundredths, which implies the answer here that we shall get is 0.05. You will notice that when you look at the answer that we have, the first column, which represents tenth, is 0. But the second column, which represents hundredths, we have a digit 5. That's why this is 0.05 and not 0.5. So the 5 lies in the second column of hundredths. Solution for the third one is here, 317 over 1000. Earlier on, we said a decimal point separates part of the whole number and the right-hand side part of the decimal part or the fraction part. For this case already, we have a decimal part and we have got a whole number part, which implies that we shall not tamper with 3 because it's a whole number. So our answer is expected to be 3 point, and then we look at the other side. For this particular case, we shall have 3, then in that case, and as we look at 3, this other part, where we are supposed now to have point something, we need to find out what does this 17 over 1000 mean. You realize that 17 over 1000, if you were to look at it, it is the same as simply 17 multiplied by 1 over 1000. So you'll notice that this is, we have 2 digits here and we have 3 zeros as our denominator here. Then it will mean that 2 of the digits will be taken by 7 and 1 from the far end, and then we remain with a 0. So in this case, changing this will be 1, 2, 3. So 1, 2, the third one comes there. So it will be 3.017. Now 1 and 7 are in a different column of place values. But the farthest should be the thousandths, which is the 7. So in this case, we have thousandth as our 7, hundredth as our 1, but for tens, we have nothing. So this decimal 3 and 17 over 1000 can be converted to be 3.017. Still looking at it, let us find the easiest way maybe to handle and convert this decimal, the easiest way. As long as we have the denominator as either 10, if the denominator is either 10, 100, 1000, 10,000, it is easier to convert this. From what we had initially, we had the first one as simply 7 over 10. But as long as the decimal is here, it is very simple. A tenth means 10 means a tenth, and a tenth is at 1 decimal point. So it comes like that. So to convert this one is simply 0.7. From the second one, which we had 5 over 100. This one, we find that this is for 100th. And for 100, we count just these 2 zeros here. We have 1, we don't have the second one. We bring in the second one and then a decimal point. So this one becomes 0.05. For the last one, where we have, if we had 17 over 1000, this would be 1, 2. So we are here, we still have the third one, so we add a 0. So it will be 0.017. And that's why 3 and 17 over 1000 was the same as 3 point. Now we have, that is a 0.17 as our decimal. As long as the denominator is in the form of tenth, hundredth, thousandth, we can handle it like that. So let us look at arranging decimal numbers in order. Arranging decimal numbers in order. Question. Arrange the following decimal numbers in ascending order. That is from smallest to largest. 3.72, 7.23, 2.73, 2.37, 7.32, and 3.27. 3.72, 7.32, 2.73, 2.37, and so on. We are supposed to arrange them in ascending order. Now, here we shall look at them from all categories. It is easier for us to identify from the whole number side and identify which one is large. For example, whole number here is 3, whole number here is 7, meaning 3 is less than 7, 2 is less than 3, and so on. So you'll find that we are able to identify them by simply looking at the whole numbers. Having done with the whole numbers first, then we move to the second area. So we consider in our solution here, we consider the whole numbers. When we consider the whole number part, we are looking at 3, 7, 2, 2, 7, and 3. Where they tie, for example, where they'll tie, because in this case we are able to just know, but where they'll tie, for example, we have 7.23 and 7.32, 7.23 and 7.232. Where they tie like this, I want you to notice that the 10th column has got a higher value than the 100th column. So if we have 7 in the whole number, it has tied. But the 10th column, the first one has a 2, the second one has a 3. So we are saying that this one carries weight. So between 2 and 3, which one has got more value? It is a 3. So you'll find that then 2.23 is smaller than 0.32. We also look at it, if it was comparing with 100, then the 10th value, the 10th value carries a higher value compared to the hundredths. So when the whole numbers tie, we look at the place values. So when you rearrange these, considering that, this is one here, we already see that from this, we already see that 7.32 is greater than 7.23. Another one that also tied here is a 2. We have a 2 here. Now, this is 2.73, and this one is 2.37. Again, 10th here we have 7 over 10. This is 3 over 10. Definitely these two, we proceed, we have 2.73 is greater than 2.37. The other one that tried is 3 and 3 here. And 3, we can see this is 3.7, this is 3.2. Definitely this one is greater than the other one. So 3.72 is greater than 3.27. So from there we can simply rearrange now, and from the smallest. The least is 2 points. You can see that from the 2s, then we come to the 3s, then we move to the 7. So you'll find that in ascending order, we shall have 2.37 followed by 2.73 followed by 3.27 followed by 3.72 followed by, in the 7 category, we found that 7.23 is here. 7.32 is greater than 7.23. So, which means 7.23 comes first, and lastly 7.32. So if we were asked for the order of ascending, this will be our order, where we have 2.37, 2.73, 3.27, 3.72, 7.23, and 7.32. That is how we compare decimals and arrange them in a given order. If you are asked in a descending order, then we would start the reverse of this from 7.32 backwards up to 2.37. That is it for today. And in our next class, we shall be looking at rounding decimals. Thank you.